Hello everyone. In this video, we are going to study about the variance and how to calculate the variance for discrete series. Previously, we have done a video on how to calculate the variance for individual series. This is for the discrete series. So we shall move on. So what's the discrete series? You know already. So it is given with the frequency. See, so x has come 2 times. See, this 10 has come 2 times here. Now 30 has come 3 times, 20 has come 4 times, 40 has come 1 time. This type of data, we are using it for the discrete series. So how to calculate? So we'll be dealing with 3 formulas here. The first formula, we are going to have this sigma square is equal to sigma f into x minus x bar the whole square divided by n. Most probably this direct method. So we are talking about a population here. Okay, now population. See, I've given a formula for population. You can note it down here. Okay, now sigma square have you used. So I am using n here. Suppose if this is a sample, then the formula will change sigma f into x minus x bar the whole square divided by n minus 1 will be there. You know, whenever there is a sample, I'll use n minus 1. Whenever there is a population, I'll be using n only. Now population, I'll be using sigma. For n, I'll be using s. So suppose if you have any clarity, if you don't have any clarity for this, just visit our YouTube channel for the previous one. We have done an individual series. There we have explained why we have to use n minus 1 and where we have to use n minus 1. Okay, so now another formula, we will be using it as the shortcut method. Okay, now sigma square will be sigma fd whole square divided by n minus sigma ft by n the whole square. We are using it for the population. Suppose if it is the sample, then n will be replaced with n minus 1. That alone is the only one change you have to remember. All the other things are same. Sometimes in a population, x bar is written as mu. Okay, so now x bar is also mean, mu is also mean. Whenever mu is given, it is the population mean, x bar is sample mean. Okay, so only one point you have to note, sample is given, you put n minus 1. Okay, so now this is called the step deviation method. Most probably step deviation method is not a popular method to find out the variance. So the people will be using a direct method or the shortcut method only. Just if you know how to calculate mean in shortcut method, assumed mean method, and mean using step deviation method, you might have noted here that we are multiplying with h in the last. But for variance, you should multiply with h square. This alone, you have to keep it in mind. This is very, very important for variance. Okay, now mean square deviation, we call it as. Okay, so therefore, this is, you have to multiply with h square. So in the book, sometimes it will be given as root h and whole square. So many things will be written here. So don't have a confusion. Just have the clarity of multiplying with h square. So we'll be doing all the 3 methods for finding the variance for discrete series. So we'll be considering this particular thing as the population, and we are doing it. Okay, so now imagine that this population is given. We'll take it as a population, not as a sample. We are going to do it. So first of all, we have to write the x value as it is given here. You see x value here, that I'm going to write it here. Then I'm going to write the f value here as usual, how it is given. Now I am going to find out f of x, f into x. These two I am going to multiply it. Why? Because I am going to find out what is mean here. Okay, now mean formula, if you are do not know it, just write it down here, sigma fx by sigma f. To find out mean only, I am calculating this particular column. So I'm going to multiply 10 into 3, that gives you 30 here. 12 into 5, it is 60. Then 14 into, so this and all is I'm going to multiply. Okay, now this into this I'm multiplying, right? 12 into 5, 60. 14 into 9, 126. 16 into 60, okay, 256. This is 144. This is 140. This is 44. Now I'm going to total this column. Okay, this column and this column I'm going to total it here. So 50, and here it is 800. So I am using it in the mean formula now. So how to use this here? Sigma fx by n. I am calling it as n. So whenever I say n, Capital N is nothing but sigma F. Okay, so you remember capital X is sigma N. Okay, so now I got 16. I'm going to subtract that 60 from where? So X is 10. Here I'm going to write 10 minus 16. Okay, so now it comes around minus 6. Similarly, 12 minus 16 comes around minus 4. 14 minus 16, it is 2. 16 minus 16, it is 0. 18 minus 16, 2. 20 minus 16 will give you 4. And 22 minus 16 comes around 6. Okay, so now I'm going to square this particular thing. Okay, now square it. So we'll get 6 into 6, 36. 4 into 4, 16. 2 into 2, 4. Then 0, 0. So 2 into 2, 4. 4 into 4, 16. 6 into 6, 36. So I'm going to multiply this F into this. Okay, so which column I'm going to multiply? I'm going to put a star here. You can see here. Okay, this column with this column. Okay, now here. It doesn't look like a star. I'm sorry. Right. Okay, now these two columns I'm going to multiply. Okay, so now F and this column. So 3 into 36. Okay, comes around 106. Similarly, 5 into 16. Then 9 into 4. Then 16 into 0. Then 8 into 4. Then 7 into 16. Then 2 into 36. Okay, so now I'm going to use the formula for this. Right. So now I total it as usual. 440 is coming. Right. Now I'm going to use the formula. Sigma square is for the variance. So I'm going to write the numerator as 440 divided by 5. So I'm going to cancel this. You can calculate using a calculator also. Now 44 by 5 comes around 8.8. So now this is how we will calculate variance in a direct method. So now we are going to use a shortcut method. How to do the shortcut method? So here, the same thing, I'm going to write it here, finished. Here, I'm going to assume a value of X. Okay, most probably from center, I will take, for clarity, I'm going to take one extra here. Okay, now I'm not taking 16. I'll be taking 16 in the next sum, so that you will understand. Right, now I'm taking this A, right? Now I'll take this as my A here. Okay, now this is the assumed mean, whatever it is, step deviation method. So assumed value. Okay, assumed value I'm going to take. So now 14 I'm taking. So I'm subtracting this 10 with that 14, right? So 10 minus 14, I should find it out. So how much it is coming? Minus 4. 12 minus 14, 2. 14 minus 14 will give you 0. 16 minus 14 will give you 2. Now 18 minus 16 will give you 4. 20 minus 16 gives you 20 minus 14. Sorry, 20 minus 14 will give you 6. Then 22 gives you 8. Now, what I'm going to do is here, this is D here. I'm going to square it. Square the value of D here. 4 square is 16. 2 square is 4. 0, 4, 16, 36, and 64. Then the two columns which I'm going to multiply. This time I'm putting a star. Okay, this is how I'll draw a star, right? This FD, how I'm getting it? F and D I'm going to multiply here. Now, this star multiply with this star, which gives you here. Okay, now F and D. F is 3, D is 4. So 3 4s are minus 12. 5 2s are. Okay, now 5 and 2. I'm multiplying and writing here 10. So 9 0 0. 16 2. 32. 8 4. Then it's 32. 7 6. It is 42. 2 8. It is 16. Then which two column, next two columns, this F column with the D square column, I am multiplying and writing here. Okay, now F is 3 here, D square is 16. So 3 into 16. So 48, 5 into 4, then 9 into 0, 16 into 4, 8 into 16, 7 into 36, then 2 into 64. So now I'm going to total it here, this total and this total. Both three totals. I'm going to find it out. Then I'm using a formula here. Now variance is sigma FD square. You must be very, very careful. FD square is a column here. Okay, now here FD divided by N, I am making it as a whole square. Very, very important. You have to remember sigma FD square by N. So it is I'm going to substitute the value. It is 640 by 50. This is 100 divided by 50, the whole square. So then comes around 640 by 50. This is 2, right? 2 power 2 will give you 4. Then I'm subtracting and finding out. Then the value is 440 divided by 50. So 8.8 is coming. So sometimes you do not know how we have calculated here. I'm going to write it here. You see 640 divided by 50. Here I'm getting 4. Okay, 100. Divided by 50, which gives you 2. 2 square is 4. Then I am going to cross multiply this. So 640 and minus 200 divided by 50. 640, 200 means it is 440. Okay, divided by 50. This get cancels. 44 by 5 will give you 8.8. Okay, so this is the simplest way we are going to use for the variance in the shortcut method. Now, imagine I am going to have a deviation here. Okay, step deviation method. I see, just check here 2, 4, 2, 4, 6, 8. So I'll divide this whole thing by 2. Okay. Now this 2, I'll call it as h. Then I'm going to multiply this h in the last column. It's a less popular method. Anyway, we'll be doing the same thing in step deviation method also for clarity. So I would suggest you can go for the shortcut method instead of step deviation method. Okay, sometimes you'll be having a confusion whether you have to multiply with h square or h and all. Okay, so you can use shortcut method directly, not the step deviation method. So anyway, we are going to learn the step deviation method also here. Okay, so now how to find out the step deviation method? The similar way, x I'm writing, f I'm writing. The only point what I'm doing is here, I am going to take 16 this time. Okay, so for clarity, okay, you can take 14 also. I'm going to take 16 as my assumed mean. So this formula I'm going to calculate here. Okay, so I'll write it in the top. You can see now. Now, what is my x value? X value is 10 here. What? 16 I'm subtracting divided by 2. 2 I am choosing. Okay, you can choose any number here which makes this particular column smaller. Okay, sometimes people will say you take this difference, 10 and 12 difference, you take and divide it. It's not like that. So whichever number you want, and you can take that for reducing the number which is given here, because whatever the number we are putting it here, we are going to multiply at the last step. So if you take 10 also, it is fine. Even though the difference is 2 here, you can take 4 also, whichever is comfortable for you to make this particular column less. Okay, there is no hard rule for you. Now I'm going to find it out. Minus 4 by 2, I'll get minus 2. This is what this the calculation. I'm going to write it here. Okay, so I'm sorry. So I made a mistake somewhere. Right. Yeah, 6. 6 by 2 is 3. Right. Yeah. Now, so now 12 minus 16 divided by 2, which gives you 2. Now 1, 0, then 1, 2, 3. So it follows a pattern. You can always see. Now I'm going to square it here. Now d square 9, 4, 1, 0, 1, 4, 9. So now I'm going to multiply f, right? So f is here and d is here. These two things I'm multiplying and writing it here. Okay, now 3 into 3 minus 9 here. Here minus 10. Then 9 into minus 1 will give you. Now this is 0. This is 8. This is 14, this is 6. Now d square I'm multiplying. So this 3 I'll multiply with 9. Okay, it's 27. 5 multiplied with 4 will give you 20. 9 multiplied with 1 will give you 9. 16 multiplied with 0 will give you 0. 8 multiplied with 1 will give you 8. 7 multiplied with 4, it gives you 28. 2 multiplied with 9 will give you 18. I'm going to total it now. Okay, so now this column I'm totaling, this column I'm totaling, this column I'm totaling. Please note 0 has come. That is why step deviation is used. So one of my calculation will be easy for me to do. So now I'm going to use the formula. Note down this particular thing, very important. You are multiplying by h square. Okay, not h. You have to remember. Okay, in mean step deviation method, we are multiplying with h or c or I. Okay, anything maybe, right? So now here I'm using it as h. Okay, you have to remember. Now I'm going to substitute the value here. 110 from here I'm taking. Now 0 from here I'm taking. Then 50 from here I'm taking. I'm just substituting it. 2 will be whichever the value I am dividing it here. Okay, now that is called 2 here. Okay, now that is the value is h. That value I'm going to take it here. Now 2.2. So now when you calculate here, 110 divided by 50, right? So now 11 by 5 will give you 2.2 into 2 square is 4. So my value comes around 8.8. This is how you will calculate the variance for step deviation method. Okay, variance for discrete series. So we have studied three methods here: direct method and shortcut method and step deviation method. Okay, thank you very much for watching. If you have any doubt, just comment and have a good day.